Hi guys, this is Alan Saxena and welcome back to my channel. This is part 2 of Numpy for beginners. In part 1, we have seen how to install Numpy, create an array, indexing in Numpy, array slicing, reshaping an array and joining arrays in Numpy. So if you are not familiar with these topics, I would suggest you that you go on and look at the part 1. I will provide a link in description box for it. In this part, we are going to have a look at some more topics such as ufuncs, aggregations, broadcasting, Boolean logic and comparisons, sorting in numpys, and structured array. Before moving forward, if you are new to my channel, please subscribe for more updates on data science and machine learning. So, without any delay, let's get started. Our first topic today is universal function, commonly called as ufunc. By definition, a universal function or a ufunc is a function that operates on n-dimensional arrays in an element-by-element fashion, supporting array broadcasting, typecasting, and several other standard features. So basically, ufunc are some functions provided by Numpy that provides you to perform some sort of operation on n-dimensional arrays. So today in this video we are going to discuss few operations such as arithmetic operation functions, absolute value functions, trigonometric functions, and exponents and log functions. So first we are going to see arithmetic operations. Here you can see I have mentioned few operations that you can perform using Numpy ufuncs, such as addition, subtraction, multiplication, division, and so on. So let's go ahead and try some of these operations by ourselves. So our first step is to import Numpy. For that we type command import Numpy as np. So we run this. Okay, let us create two different arrays to perform operations. First we'll name it as x and we'll use numpy np dot a range, and we'll provide a range from 10 to 20, and we'll print this. So this function will create an array and it is ranging from 10 to 20. That means it has 10 different values. Similarly, we create array y and it will range from 0 to 10. Let's print this. Now let's say we want to perform addition on these two arrays, so that we have to add these two arrays, that is x and y. For that we can simply use the built-in function np.add, and in the curly braces you provide these two arrays, that is x and y, and if you run this, the result will be the addition of two arrays, that is x and y. Here you can see it has added array element by element. So the 10 of array x is added to 0 of y, and similarly 11 of array x is added to 1 of y, and so on. Similarly, if we want to perform multiplication, we give np dot multiply, and we give two arrays x comma y, and hit enter. Okay, it is, oops, and we run this. We get the multiplication of these two arrays. Similarly, you can use all these arithmetic operations and play around. Next in ufunc comes absolute value functions that can be performed by two different methods, that is np.absolute or np.abs. So let's see how we can perform these two functions on an array. For that, let's create an array first. Is equals to a range, and we give range from -4 to 4, and let's print this. So once we have the array, we can check the absolute value for this. For that, we give the command np.absolute and then pass x as an argument. So here we go. So the function has provided us the absolute value of array x. We can also use another function np.abs for the same purpose. Absolute function can also be performed on complex arrays. So let's create one. Let's run this. Okay, this y is my complex array. Now if I want to get the absolute values of y, all I need to call is ufunc np.abs and then pass y as an argument, and if I run this, I get the absolute value of complex data y. Next comes trigonometric functions such as sine, cos and tan. So let's see how they work. First, let us create an array x, np.arange 1 to 10, and let's give a step as well of 0.1 and print it. So we have these many values. So let us see how many values in exact we have. For that, you can check the length of x. So we have 90 different values. We need to apply ufunc np.sine and then pass x into it. So basically what it does is it will create an array, that basically an amplitude for given array x, so that it creates a sine wave. So this is what it represents. So if you print this y, you will get an array which represents a sine wave. So I know it doesn't looks very good because you actually don't know that whether it's a sine wave. So let's go ahead and see that how you can represent these points on a graph. So for that we need to import matplotlib. let's plot x and y. Let's give title as sine wave, x label. So x label is actually my points at x, and let's take this as a time so that it's easy for you guys to understand. So x is basically my time, and let's take y as my amplitude. And let's provide a grid tour map. So what type of grid? Let's grid is true, and which is both. So we have title, we have label, or we have to give x label and y label, and we have grid. Now we can go ahead and plot this, plt.plot, and let's see what it returns. So here you can see it has returned me a sine wave. Looks good, right? Similarly, you can create a cos wave as well. For that, let us create another y. So for that, you give np.cos, and again pass points of x, and you run enter. So if you go ahead and plot these points again using same code, let's copy this and paste it. Now we need to change this as cos wave, and everything else remains same. Let's go ahead and run this. Here you can see we have a cos wave. Similarly, for 10, we can give y is equals to np.10 and pass x again, and we plot it. Okay, so here we have a 10 wave. Next comes exponents and log functions. So let me quickly give you an example on how to use them. To perform exponent function e power x, you have to use np.exp and give the array x. So let's create an array x first. np.array, so if you want to apply the first function, that is e power x operation, then we need to use np.exp and then pass our array x. So this is nothing but the exponential points of x, that is exponent of 1 is 2.71, exponent of 2 is 7.3, and so on. Similarly, if we need to apply 2 power x operation, we can use ufunc np.exp2 and then pass the array x. x2 and x. We can use np.power function, and then as an argument you can pass the power which you want to apply, let's say 3, comma, and the array on which you want to apply this operation, and run it. Similarly, we can perform log of an given array x. For that we need to use the ufunc np.log, and then pass array x. If you run this, you get the log of x. So this is the base 1, so log base 1 of x. So if you want to get log base 2 of x, you give np.log 2 of x. And similarly you can get the log base 10 of x as well. Next important topic in the pipeline comes is aggregation functions, such as if you want to find out minimum, maximum, mean and standard deviation of a given array, you can use these functions. To demonstrate this, I have imported a height weight dataset using pandas in my data variable, and this is how my data looks like, which has gender, height and weight columns. So I have extracted the height column in my height variable, and we are going to perform aggregation functions on this height column array. Now let's see what is the minimum and maximum height of the given data. For that you need to use the function np.min, and then you can pass on height, and run this in. So you can see that 54.26 is my minimum height. Similarly, you can check the maximum height as well. Okay. So 78.99 is my maximum height. So if you want to round off this particular maximum height up to 2 decimals, you can use the function round. And you can give 2 as an argument for 2 decimal values. So 79.0 because it was 99. So if you give 3 here, it will give 78.999. Similarly, you can check the standard deviation and median of the given height. Standard deviation of height. So my 0.384 is the point for standard deviation, and if you want to check my median height, you can use function median and pass on height. So 66.31 is my median height. Again, you can round off this using round function. To 2 decimal values, and if you run this, we get 66.32 as my median height. So this is how you can use aggregation functions on real-time data. So our third topic is Boolean logic and comparisons. In this topic we will see how to use comparison and logic operators that returns Boolean results. So first we create an array. Here I have created an array of size 3 by 4 and the values will range from 1 to 100. So let's run this. NP is not defined, so we need to import NP first. That is my Numpy. And run this. So we have set of values that are ranging from 1 to 100 and the size 3 by 4. Now if you want to check if any of value in your array is greater than 50, that means if any of the value in this particular array if greater than 60, then they should return true, otherwise false. So if we go ahead and run this, that it returns true. That means definitely I have some value in the array which is greater than 50. Similarly, if we want to check if any of the value is less than 0, we can go ahead and run this. So which is false. As you can see here, we don't have any of the value which is less than 0 or a negative value. Also we can check if all of the values are greater than 0. If we go ahead and run this, it returns true. That means all of my values are definitely greater than 0. Similarly, you can check if all of my values are equals to 30, which is definitely not the case, so it should return me false. So if you want to see like for each and every element what exactly is the result or what exactly is my Boolean result on each and every element, we can simply give this type of operation such as x greater than 60, that means my array greater than 60. It will go and check each and every element in my array and check whether it is greater than 60 and returns me Boolean array satisfying the results. My first element is definitely greater than 60. My second element is again false. Third is again false and fourth is true. Similarly, we can see how we can use logical operators and get the Boolean results. So if you want to apply logical AND or XOR or NOT, you can use in the given way. So if you want to check the values which are in between 60 and 90, that means my x is greater than 60 and my x is less than 90. So if you go ahead and run this, it will return me a Boolean array. So if you want to get the sum, that how many values are in between 60 and 90, then you can use sum. Okay, we have to give np.sum. Only 3 values are in between 60 to 90. Similarly, we can use OR operator as well. If you run this, that means all my values are either greater than 60 or they are less than 90. So if you want to apply logical NOT on this particular operations, you can do it. So if you want to apply NOT on this, you can copy. So you can apply NOT like this. And if you run this, so this will give me NOT of this particular operation. That means it is showing me results except which are in between 60 and 90. So if you want to get the sum of these particular value, you can use np.sum. So we have 9 values which are not in between 60 and 90. The fourth topic is sorting. So let's see how we can perform sorting on a given array. So let's first generate an array of size 10. So if we want to perform sorting on this given array, we can use np.sort and pass array as an argument. And if you run that, similarly we have another function called argsort. So basically it returns sorted indices, that is index numbers, instead of array numbers. So if I run this np.argsort, it will return me the sorting of the index numbers instead of the values. So for example, the value at the 9th position is actually the smallest, that is the value 0, right? And so on. The 7th value, that is the 8th one, is the second in the array. This is how you can sort values on an array. Next, see how we can perform sorting on an ND array. So let's create an array of shape 5 by 2. And if you want to perform sorting along the columns, you can give axis is equals to 0 as an argument in the sort. So if you run this, you will see that our array is sorted along the columns. So for example, if you see here in the first column, my values are sorted like 9, 29, 64, 73, 89, and in my second column 0, 8, 15, and so on. Similarly, if you want to perform sorting along the rows, you can use np.sort and pass the argument axis as 1. So if you run this, you will get a sorted array along the rows. So if you see in this row, 9 is my smallest value and then comes 15. Similarly, in the second one, 28, then comes 64, and so on. Fifth and last topic of today's tutorial is structured data. We can create structured data in Numpy using np array. Here in this example, you can see I have a list, and in this list I have two different set of values. So each set has different elements, that is different values, and each value belongs to a different data type or a different column. So for example, if we consider this particular set, I have Rex 9 and 81. So Rex basically is my name, and it has a data type U10, which is Unicode string of maximum length 10. 9 here represents age, which has a data type I4, which is integer of 4 byte. Similarly, 81 belongs to my weight category, and the data type for it is F4, which is float of 4 byte. So if I go ahead and run this, I will get a structured data array. So if I want to access this particular set or the set at the first index, so what I can do is mention that particular index. So if I run this, I will get the whole set of values at the first index. Similarly, if I want to know what all data are fed under the data type name, I can go ahead and pass name as an argument in X in this particular manner. So if I run this, I can get all the elements under name data type. We can also assign values to different data types. For example, if I want to assign values 10 and 20 to my data instead of 9 and 3, what I can do is I can write X and in square bracket age, which is the data type I need to change, and the exact values what I want to feed in, that is 10 and 20 under in a tuple. So if I run this, my data type age has different values which I have set, that is 10 and 20 now. Similarly, if I want to assign same values to a particular data type, I can give value in this particular manner. So for example, I want to assign 50 weight to both the sets. I can give x weight is equals to 50, and if I run this, I'll see that the weight 50 is assigned to both the sets. So this is how you can work on structured data. That's all for today's video, and see you in the next one.